Good evening and welcome to this presentation on Open Data Science for All, a new approach to data science education. My name is André de Waal. Before I start, a bit of background on myself. I was born in South Africa, where I completed most of my undergraduate and graduate education before I moved to the United Kingdom and enrolled in a PhD in theoretical computer science at the University of Bristol. After finishing my PhD, I spent 6 months in Germany and also 6 months in Belgium doing postdoctoral research before I returned to South Africa, where I became a founding member of the Center for Business Mathematics and Informatics, where I taught data mining, neural networks, and artificial intelligence. During 2010, I moved again to the United States and started to work for an advanced analytics software company. During the middle of 2019, I joined IBM as an ecosystem data science and AI program university lead. So what is Open Data Science for All? Open Data Science for All is an open education project designed to accelerate the development of data science curricula at academic institutions. There are more than 250 master's programs in the US specializing in data science, business analytics, and data analytics, and also a small number of undergraduate programs. But the growth in demand for data science skills currently outpaces the ability of all these academic institutions. This is true all over the world to generate and produce enough data scientists. Looking at this graph, you can see a steady increase in the number of data science programs, but even with this growth, there is still a shortage. This graph is courtesy of Professor Michael Rapper from the Institute for Advanced Analytics at NC State University, where the first master's degree in advanced analytics was started. Multiple organizations are building face-to-face data science programs. This is relevant to K-12 community colleges, universities, other service organizations, and also for corporate training. But there is an opportunity to develop a set of data science materials that are available to everybody at no cost that can be used to accelerate the design of educational programs in data science. So Open Data Science for All is basically a curriculum kit built on open source principles and on Python. The curriculum kit, as we call it, or modules, was built by 2 professors from the University of Pennsylvania with a couple of their PhD students based on a specialization in data science. We launched the project as an open source project under the Linux Foundation governance to ensure automatic updates and growth. The project went live at the end of February 2020. So the goal of OpenDS4All is to enable organizations, and this could be educational organizations or privately held companies, to build their own data science educational programs to accelerate the production of data scientists. Here at the bottom, you can see our GitHub address. So as this is run as an open source software project, the project is hosted on GitHub. Currently, the repository consists of 15 modules or 15 lessons. And we try to cover the whole span of data science. Obviously, with only 15 modules, you cannot cover everything in data science. So there are opportunities to contribute to the repository. The first module is an introduction to data science from a perspective of big data. The second module covers some fundamental concepts on computers and discusses memory and CPU. It's always important where you get your data from. So the next module is kind of an introduction to data science, focusing on data acquisition and data wrangling. And we have a really neat notebook that scrapes information from the web and tests a hypothesis. And I'll come back to this Juputer notebook in a couple of slides. Before you start with the fun stuff, that is the modeling and building neural networks, you have to understand your data, and information visualization or visual analytics is very important, especially in the world of big data, so that you can reduce your data to a couple of slides or graphs to understand the distribution of your data and perhaps detect some outliers. The next 5 lectures or modules focus on scaling to big data and the cloud. So we live in a world with big data, and cluster-based processing of graph data is then one of the modules. Now, in the world that we live with search engines and social media, there are many graphs that we would like to analyze, who is connected to who, and it's very important to be able to efficiently process graph data. One of the most famous algorithms out there, PageRank, that Google uses to rank the pages of the search engine after a search request, is covered in one of the modules, so network centrality and PageRank. And then the last module in this group is PageRank and graph analysis using linear algebra. We then have 4 modules focusing on machine learning. The first module focuses on unsupervised machine learning, and it covers k-means clustering and principal component analysis. The next module gives an overview of supervised machine learning and covers decision trees and random forests. The following module covers linear and logistic regression, and then the last module in the machine learning group focuses on artificial neural networks. After you've built your machine learning models, you have to pick the best one to put into production, and there's a module then on training robust models to help you to select the most appropriate model. In the world that we live with data breaches and unethical use of data, data science ethics is then the last module, and it's extremely important for such a course. Most of these modules cover a lecture of 50 minutes, but some of the modules, like the artificial neural network module, needs 2 or 3 50-minute lectures to cover. We have a technical steering committee made out of professors in the US that will help to steer the project in the right direction and also help to preserve the integrity and ensure the integrity of the content. The professors on the technical steering committee is, first of all, David Mongo. He's the executive director of the Berkeley Institute for Data Science, University of California, Berkeley. Then the 2 professors that developed the initial 15 modules, Professor Susan Davidson and Professor Zach Ives from University of Pennsylvania. We also have Professor Jennifer Priestley. She's professor at the Analytics and Data Science Institute at Kennesaw State University. Professor Eric Labar is professor at the Institute for Advanced Analytics at North Carolina State University, where the first program in advanced analytics was started. Then we have Professor Gautam Chakraborty. He is a professor at the Spears School of Business at Oklahoma State University. My manager, Anna Isheveri from IBM, and myself are also part of the technical steering committee, and I'm the chairperson of the steering committee. Then we have the last member, James Haroon. He's from SAS Institute. So let's go directly to GitHub and talk about OpenDS4All. So as you can see from our front page, this project was created to accelerate the creation of data science curricula at academic institutions. But as I also indicated, this doesn't need just to be at academic institutions. It can also be companies that want to upskill their personnel in data science. The Juputer notebooks and the code are licensed by an Apache 2.0 license, and we are fully integrated with a binder. So this is an executable environment where you can, with one click, execute the Juputer notebooks in the repository. There are some prerequisites for students that want to take some of these modules. First of all, students must be comfortable and have some familiarity with programming in Python. They don't need to be Python experts, and also some familiarity with probability theory and very basic statistical notations. Think of the modules in the repository as Lego blocks that can be used to construct a data science curriculum or specialization. So these modules can be used to teach at undergraduate and graduate level. On this slide, you can see the hierarchy showing how the modules are organized into categories. The first category contains an overview module, an overview of data science. Then we have a category of foundational material. At this stage, we do not cover mathematics and statistics, but we have a small number of foundational lectures on computer science. As I explained in the introduction, data wrangling and integration is extremely important in the data science process, and I'll show a Juputer notebook implementing what is described in the lecture in a couple of minutes. Exploratory data analysis, very important step. So we have a module on that. It's also very important how you represent your data. You can represent your data as logical statements or as a flat file using an SQL database or a non-SQL database. This is covered in this module on data and knowledge modeling. In the world of big data, scalable data processing is extremely important, and especially where you have graph data from social media and other analyses. We have a couple of modules on that, and Apache Spark is then used to do the distributed and parallel processing for you. Then we have 4 modules on machine learning. As I explained, 1 module on unsupervised machine learning and 3 modules on supervised machine learning. We have a category on model assessment, picking the best model after you've built a number of models, and then 1 module on ethics. There's also a module containing further instructor resources. So this is a living repository, and as more contributions are made to the repository, we will add new categories. So for instance, we are thinking about adding a use case category. So if we have a nice use case illustrating some of the components in this topology, that would be really interesting to show that to the students and have a different data set to explore. In the Instructor Notes, we have some recommendations on books that students might want to consult on Python. And as I explained, the material was developed at the University of Pennsylvania from their CIS 545 course on big data analytics. So they are using the material, and we also have a list of adopters that we currently have and also update as we gain more adopters. Currently, we have 3 universities in addition to the University of Pennsylvania that use some of the material, Kennesaw State University, Oklahoma State University, and then the University of North Carolina at Charlotte. There are many ways that you can mix and match these modules to arrive at a program or a curriculum. Here we give an example of how to construct a data science program using some of the core modules that's available. You could start with an overview lecture, 1.5 hours, and as you can see, we also give an indication of the difficulty level of the module. So the overview module is described as a basic material. Then you can follow that up with a module on data acquisition, wrangling, integrating, and cleaning data. And that might require a couple of lectures to go through the PowerPoint slide decks. And this might be slightly more difficult material. You could follow this with a module on modeling data types, graphs, and schemas. And you also need a couple of hours for that. And then move on to performance, foundations of computer architecture, and then efficient data processing, which is of intermediate difficulty, and you might need more than a couple of hours to cover the material. You could then follow on with the machine learning modules. So as I explained, we have 4 modules, one introductory module on unsupervised machine learning, covering decision trees, and I'm mistaken there, so covering principal component analysis and k-means clustering. Then we have 3 modules on supervised machine learning, covering decision trees, random forests, linear and logistic regression, and then neural networks. As I indicated, you might also need more than one, probably 2 or 3 50-minute lectures to cover all the material on neural networks. You could end your program with a module on validation and the tuning of modules. Then if you have time left, you could add in modules on data ethics, data exploration and visualization, and then additional material on big data and the cloud. Going further into GitHub, this is the view when you get to our landing page, and there you have a folder, Open Data Science for All resources. If you click on this folder, it will take you to the hierarchy and then further on to the actual PowerPoint slide decks and the Juputer notebooks. So this is an exact mirror image of the what you've seen in the topology. So there are the categories as you saw in the diagram. So let's go to one of these categories and let's go to the overview material. As you can see, we have a set of PowerPoint slides, some instructor notes, a quiz, and there's no Juputer notebook for the overview set or overview module. When you click on the set of PowerPoint slides, you need one more click to download and open the set of PowerPoint slides. And as you can see, this set of PowerPoint slides is the introduction material, what is data science. So the slides are really well developed with instructor notes. So to give guidance to anybody that wants to teach the material and understand what the initial intention was of the professor that actually created these slides. If you go to another category, this time data wrangling and integration, we see that there is a set of PowerPoint slides, but there are 2 Juputer notebooks. So the first Juputer notebook complements the material that was discussed in the set of PowerPoint slides. And then we have a homework assignment as well. So let's look at the notebook under the data wrangling category. In the first cell, we have to install our Python packages, and you'll see some familiar packages like matplotlib, pandas, and numpy, but also some packages that you might not have used to help you with the web scraping. The second cell then imports some of the modules that are needed to execute the code in the rest of the Juputer notebook. So the Juputer notebooks are divided into sections, and the first section then gives a short description of the problem and gets one of the data sets that we're going to use in this notebook. So the idea behind this notebook is to get information about companies and CEOs, extract the age of CEOs, and then to test the hypothesis that CEOs are generally older than 40 years. So the first cell over here goes to a web address to get the companies.csv dataset, and then we persist or store the dataset in an SQL database for further use. At the end of the notebook, after a lot of data cleaning and merging of datasets, we arrive at the distribution of age of the CEOs, and we can clearly see that most CEOs were born after 1980. If we go to the machine learning category, we see that we have the 4 machine learning modules. Each module has a set of PowerPoint slides and an accompanying Juputer notebook. We also named the modules so that it's easy to see what key features are described in the module. So we have keywords, for instance, for the unsupervised machine learning, matrices, principal component analyses, and clustering, and the indication of the difficulty level that is basic. If we go to one of the other modules, so supervised machine learning contains an overview, discusses decision trees, forests, and it is of basic difficulty. The neural networks are of intermediate difficulty, and there's one homework assignment as well. So what do we ask from you listening to this presentation? We are trying to build a community to contribute content to the repository and also use the content that is available in the repository. So we are calling on you to become contributors. So it can be faculty, but it could be anybody knowledgeable in data science that wants to contribute to the repository can contact us and prepare a submission to the repository. We are also looking for committers. Those are faculty and other individuals that would like to be deeper involved in the running of the actual project and help to steer and guide the project on a day-to-day basis. We are also looking for adopters that are universities and companies that want to use part or all of the content in the repository. So if you are interested in becoming part of this community, you can contact me, Andre de Waal, and there's my email address, or my manager, Anna Echeverry, and we will be happy to work with you. Thank you.